This is part 2 of Lecture 5, and I will be covering the topic of critical infrastructure. Critical infrastructure is an enormous field, so understand that this is not comprehensive. It is simply a familiarization. And once again, my goal is to make it so that you have some level of familiarity with these concepts, so you will succeed in your respective public safety field, if for no other reason so that you have a sense of what people are talking about. To that end, here is an item of note. You may hear critical infrastructure called CIP, which stands for Critical Infrastructure Protection. More recently, it is also referred to as CIKR, which stands for Critical Infrastructure and Key Resources. If you go through FEMA materials that talk about CIKR, know that in the field of emergency management it is one and the same as CIP. Also, critical infrastructure is usually referred to in the context of homeland security. While these things certainly can and are damaged during natural events, the planning that an emergency manager engages in with these resources is frequently under the guise of homeland security and our protection against willful misdeeds. So here's what FEMA writes about critical infrastructure. Their assets, systems, and networks, whether physical or virtual, so vital to the United States that their incapacitation or destruction would have a debilitating effect on security, national economic security, national public health or safety, or any combination thereof. The definition points to assets and systems that contribute to our physical security, our economic well-being, public health, etc. Naturally, critical infrastructure conjures up these types of images here. Bear in mind, critical infrastructure can also include banking systems, electronic defense systems, and other cyber-related resources. Today's references to critical infrastructure is vastly different than it was just a decade or two ago. For instance, were you aware that the connectivity that you enjoy via the internet across the world is accomplished through undersea cables? What you're looking at here is an open source map of fiber optic cables that lay on the ocean floor that connect one continent to another. In 2006, there was an earthquake near Taiwan that resulted in a submarine landslide that broke cables as it flowed down the seabed. Commerce, travel, communications to the Southeast Asia were significantly impacted, taking 11 ships 49 days to repair the damaged cables. And despite most of the traffic being rerouted immediately, internet delays were apparent for 2 months after the earthquake. In 2008, a ship tried to moor off of the coast of Egypt in bad weather. It cut the cable, causing internet blackout for India, Egypt, and the UAE. Phone and internet traffic were immediately slashed by 70%. These cables are connected on land at what are known as undersea cable landing stations. So here is a picture of one of them. You probably aren't going to just walk in, but it doesn't appear to me anyway to be impregnable. As I said, the locations appear to be open sourced, so they're not real difficult to find. And in fact, here is a landing station in the UK. And as I said, it's not exactly impenetrable, although that cattle-style gate, I suppose, is made out of very high-quality steel. My point here is that critical infrastructure can take many shapes, many of which we are not aware even exist. Damage to them, whether intentional or not, could be catastrophic to our way of life. Common to the emergency manager's world is the term THIRA, which stands for Threat and Hazard Identification and Risk Assessment. Emergency managers themselves, or staff that they work closely with, may conduct a THIRA. We know that each city or state has limited resources, and every dollar spent for the purpose of national preparedness must be accounted for. An important part of an emergency manager's position is serving an advisory role to governmental executives about where that next dollar should be spent. The emergency manager is, by all accounts, the subject matter expert And the city manager, mayor, or other official will likely call upon that person, call upon you, to describe why exactly the next $10,000, $100,000, or $1 million should be spent on a given project. One method for making that determination is by conducting and using a THIRA. It's a standardized risk analysis process that is employed every day to help communities determine where to put that money. And here is the actual THIRA process. So you can see here, first of all, you identify threats and hazards of concern. In other words, you have to ask the question, what is of concern in my community, in the community that I serve? Secondly, you give the threats and hazards context. So you would ask the question, how would it negatively affect the community if something happened to this piece of critical infrastructure? What are the life and safety implications? Would it affect the actual identity of the community? Is it a historic artifact that is irreplaceable? The third one here, establish capability targets. So using the core capabilities of the national preparedness model, how does each of these meet that goal? How can we match these capabilities to keep the sites safe? And then lastly there, apply the results. So in other words, what do we have to make it happen? There is sort of a cost-benefit analysis applied. The THIRA is only one tool to evaluate risk in the community, but it is commonly used among emergency managers nationally. As I mentioned, being familiar with threat assessments is a regular part of the job, but it can become extremely technical, which means it can be advantageous to have staff that conduct the assessments on your behalf. At some point, structural engineers, IT specialists, ecological specialists are all personnel that may be needed to get the best answers about the realities of threat and vulnerability assessments. Gone are the days of looking at a map, picking the most vulnerable assets based on your gut, and then just going to lunch. Spending $1 million to further harden the police station while failing to spend maybe just $10,000 to protect your city's entire water supply may be classified as a major blunder. So just know that this stuff has truly become science, and the stakes are too high to make a mistake.